So in module 1, so this is session number 5. In the previous session, I discussed about some of the concepts of ER modeling, that is definition of entity, definition of an attribute and types of attributes, and the definition of entity type and key attribute. So the topics that will be discussed in this session are relationship and relationship types, recursive relationship types, and role names with corresponding to the relationship type. Constraints on relationship. So there are two types of constraints, cardinality ratios and participation constraints. Together they will be called as structural constant. Weak entity types and notations for writing an ER diagrams and some example ER diagrams. Finally, these topics is followed with some of the multiple choice questions. First of all, let us try to understand what is the definition of relationship. Relationship links two entities together. So it can be called as an association among two entities. So relationship is going to relate two or more distinct entities with some specific meaning associated with them. In the example that I have given here, so employee is related to project. In what way it is related? So we have discussed in the requirement section that employee works on project. Here employee John Smith works on project named as product X. Employee works for department. So there is a link or association among entities employee and department here. So I do have one diagram here. So here is the diagram. So this is the relationship instance diagram. Employee works for department. Employee is an entity type, whereas E1, E2, E3, E4, E5, E6, E7 are instances of entity type employee. So works for is called as relationship type. Mathematically, the relationship type can be defined as a set of relationship instances where an entity is associated with another entity. In this case, E1 is associated with D1 via the relationship instance R1. Now I can say that relationship set is a set of relationship instances that associate two entities. E1 and D1 are the entities that is associated with instance R1. E2 and D2 are the entities that is associated with instance R2. E7 and D3 is associated with works for relationship via the instance R7. So the meaning of this is employee works for department. We have 3 employees in department 1, we have 2 employees in department 2, we have 2 employees in department 3. So that's about the example and definition of relationships. Degrees of relationship type is nothing but the number of participating entity types, not the individual entities. It talks about the number of participating entity types. So we have two types of degrees, binary relationship types and the ternary relationship type. In this case, works for is the relationship type. In works for, we have employee and department are participating in works for relationship type. So that's why the works for is called as binary relationship type. The degree of the works for relationship type is 2 here. Binary means 2. Ternary means if 3 entities are participating in relationship type, then it is called as ternary relationship type. So we do have the degree of this relationship type supply is 3. Supplier supplies part to the project. So now supplier S1 supplies part P1 to project J1. We have to read this way. Via the relationship instance R1, S1 supplies part 1 to J1. So the degree of the relationship type is 3 here. So we do have other relationship type also. According to the requirement, employee works for department. Many number of employees can exist for department. And also we have managers. On the same entity type, employee and the participating entity is department, we do have one more relationship type called as managers. Employee manages department. You can see here, not all instances of employee entity type are participating in managers. Only few. That means out of 100 employees, only 3 are acting as a manager. Now E3, employee E3 is the manager for D1. and E5 is the manager for D2. Sorry, E6 is the manager for D2. E5 is the manager for D3. We have only three relationship instances. So the same thing has been told here. More than one relationship type can exist with the same participating entity types. Now, employee and department are the two participating entity types. We do have two relationship type. What are those two relationship type? One is works for relationship type and another is manages relationship type. But the meanings of these relationship types are different here. So we do have other relationship types also associated with different entities. There is a relationship exists between employee and project. Employee works on project. Employee supervises employee. Department controls project. That is one more relationship instance. Employee will have dependents. There is a relationship exists between employee and the dependent table. I think I do have some diagrams here. So this is the supervisor relationship. Employee supervises employee. That means among 100 employees, few are managers to the remaining employees. So here is a works on relationship type. Employee works on project. So that's about the relationship types. In ER diagrams, we are going to represent the attributes of employee or project as relationship in some cases. If employee is working for some department, in table we have some attribute called as department number, but in ER diagram we are not going to mention that as an attribute. We are going to mention that as a relationship type. So very soon we will be I'll be displaying the ER diagram after discussing some more concepts. So the next topic is recursive relationship. Before that, I just need to tell about the role names. Role name signifies the role that the participating entities are playing. Role names, as it directly indicates that what is the kind of role that the participating entities are playing. So in this case, in the works for relationship type, employee plays the role of worker and department plays the role of employer. Employee and department. The role names are very much straightforward. So these role names are not significant if participating entity types are distinct. In this case, employee is distinct and department is distinct. So role names is not going to play much role here. So if participating entity type is similar, then there is a need for role names. For example, consider here. So entity type employee is participating in the supervising relationship twice. That means employee manages employee. So that time role names is very much necessary. Recursive relationship in the sense, if an entity type refers or relates to itself, then it is called as recursive relationship. In this case of recursive relationship, role names are very much significant. Employee plays two roles here. Once in the role of supervisor, and for the second time it plays the role of supervisee. Or else first role played by employee entity type is manager, second role is subordinate. Now for example, 1 indicates supervisor, 2 indicates subordinate. You can see here E1 is a manager for E2. 2 means subordinate. Now 2 is the subordinate of E1. Also E1 is a manager for E3. Now E1 is the manager for E2 and E3. Also E5, 1 indicates supervisor. E5 is the supervisor of E1. So entity type is participating in two roles. First role is manager and the second role is subordinate, supervisor and supervisee. So if entity relates to itself, then it is called as recursive relationship. So now the supervision is the recursive relationship type. So I have told you about the role names also. So next topic is constraints on relationship types or relationships. Constant is nothing but conditions that will be specified on dataset or tables. What kind of conditions that we can specify? There are two kinds of condition or constraint: cardinality ratio on participation constraints. Cardinality ratio specifies the maximum number of relationship instances that an entity can participate in. Maximum number of relationship instances that an entity can participate in. So for example here, if we employee exists, then it should have to participate in relationship types. The maximum number of relationship instances is 1 year. Okay. Here also this side, all the entities are participating. So there are three types of cardinality ratios. 1:1, 1:n, also called as n:1 and m:1. So we'll look for 1:1 cardinality ratio. Consider this one. One employee manages one department. So the cardinality ratio is 1:1. It specifies the maximum number of relationship instances that an entity can participate in. See, D1 cannot have two managers. Only one employee manages one department. So in all the cases, it is 1. Now this managers is 1:1 relationship type. Now we look for 1:n. Works for one employee, works for one department. N employees, here N employees, for example, you see here D1, employee 1, employee 3, employee 6 works for T1. That means N employees works for one department. That is cardinality ratio is N. The constraint is that N employees can work for one department. And the reverse is not possible. One employee cannot work for more than one department. So that requirement is not given. N employee works for one department. This is n:1 cardinality ratio. Now go for supervision. In supervision, see, one employee manages n employee. One employee, that means one manager manages n employees. So cardinality ratio is 1:n. 1:n here. So one employee manages n employees. One manager manages n employees. We go for works on. See here, one employee, sorry, n employees, E1 in D2 works for P1. That means n employees works for one project. The reverse is also possible. You can see here, one employee, E2 is working on P1 as well as P4. Here, E3 is working on P2, P3, P4. That means one employee works on, sorry, many employees works on one project and one employee works on many projects. So this is called as M:n cardinality ratio. M employees works for one project and n employees works for, sorry, one employee works for n projects. So this is called as M:n cardinality ratio. M this side and n this side. Sometimes n this side and m this side. Both are possible. 1:n and m:1. Sorry, 1:n and m:1. So this type of cardinality ratio is called as m:1. So the next set of cardinality ratio is participation constraint. So it specifies that existence of an entity depends on another entity. So entity exists if only other entity exists. For example, if you consider department, dependent entity exists only if employee entity exists. This is called as existence dependency. The branch exists only if bank exists. The student exists only if college exists. So these things are called as existence dependency. This participation constraint specifies that minimum number of relationship instances that an entity can participate. So cardinality is maximum number of relationship instances. Participation specifies that minimum number of relationship instances that an entity can participate in. Total participation. So just read through this. Every entity instance whose entity type participate in a relationship must participate in a relationship instance. Let's go for employee. Now the participation of employee in works for relationship type is total. That means all the instances of employee entity type are participating in relationship type total. It specifies the minimum number of relationship instances. What is the minimum number here? 1. If entity employee exists, then it should have to works for some department. So this is called as total. Now we'll talk about partial. I'll go for managers. Yeah. In this case, managers, not all employees are participating in managers relationship type. Sure, no? Only 3 are participating in managers relationship type. The participation of employee in managers relationship type is partial here, whereas the participation of department in managers relationship type is total. So now the partial participation is represented with single line. Partial participation is represented with single line and total participation is represented with double line. Total participation is represented with double line. We have an example here. Employee as dependent. If dependent exists, that's why total participation is also called as existency dependency. If dependent is exist, then you need to have employee entity. So that's why all the dependent entities are participating in has relationship. In case of employee, not all employees may have dependents. Out of 10 employees, only 7 will be having dependents. That's why it is partial here. This side it is partial and this side it is total. Okay, let us consider works on. If employee entity exists, then he has to work on project. That means total here. If project exists, some employees needs to work on that particular project. That means both the side it is total participation. So I guess you have understood about total participation and the partial participation. In ER diagrams, partial is represented with single line and the total is represented with double line. Very soon I'll be discussing about the notations for ER diagrams after discussing weak entity types. So the next topic is weak entity types. Entity that does not have key attributes of its own is called as weak entity type. Always, weak entities will have total participation with owner entity. Now the dependent is called as weak entity and the strong entity or owner entity of dependent is employee. Why it is called as weak entity? Because it does not have key attributes of its own. Now name cannot be called as key attribute because two dependents can have the same name. So for that reason, name cannot be called as primary key or key attribute. So it can be identified along with the particular employee. So name this partial key, this is called as partial key, that is denoted with dotted line, dotted dashed line. In ER diagram, both weak entity and its corresponding relationship are represented using double line. See, double diamond shape. And partial key is underlined with dotted line. So weak entity means entity that do not have key attributes of their own are called as weak entities. Okay. So these are the notations of ER diagrams. Strong entity is represented with a rectangle. So that is given here, employee, strong entity. Weak entity is represented with a double rectangle. So dependent is weak entity. And also we have to discuss about naming of schema construct. Relationship type is represented with diamond shape. So here employee, okay, here. So employee relates to department. So this relationship is represented with diamond shape. Identifying relationship type. If we are linking or if we are relating strong entity and weak entity, then we go for identifying relationship type. Where is that one? Yeah, here. Employee and dependent so are linked with identifying relationship type. So now dependence on is called as identifying relationship type. Next, attribute is represented with oval shape. If you can see here, ER diagram, so attributes are surrounded with oval, sorry, entity type is surrounded with oval shape. Key attribute is represented with underline the oval shape. See, in this case, key attribute is SSN, that is not visible. So it will be underlined in the department. Department number is the key attribute. Also, name is the key attribute. It's an arbitrary choice. User can select either name of the department or number as the key attribute. In case if we have multi-valued attribute, multi-valued means an attribute takes multiple values. We are going to represent this with a double oval. Now in this case, department location is multi-valued attribute. That means department is located at multiple locations, maybe Chennai, Kolkata, New Delhi. So like that, location is multi-valued attribute. If it is a composite attribute, I told that name is a composite attribute, so that will be decomposed further. Composite attribute is represented with oval, and the oval leads to another sub ovals. See, the name is composite attribute, that is divided into first name, middle initial, and the last name. Next, we have derived attribute. So age is the derived attribute. I don't think we have a derived attribute in ER diagram. Yes. Birth date is there. If I want, I can add one derived attribute. So dotted oval shape. I need to represent a derived attribute with dotted oval shape. Next, total participation of E2 in R is represented with double line. In this case, see here, dependent is having total participation with dependents of, and also project double line, employee double line. That means all the employees work for some project. All the projects will have some employees. See here, manages this side it is partial employee, only few employees manages department, not all the employees. That's why it is partial single line. All the departments will have managers. That's why it is total participation. So cardinality ratio 1:n and n:1 and m:1 is represented like this. See, one employee manages one department, 1:1 cardinality ratio. N employees works for one department. M employees works on N project. This should be m:n. One employee can have many dependents. One employee supervises N employees. N employee works for one department. So these are the cardinality ratios. N:1, 1:1, m:n are the cardinality ratios. So min-max constant is there. Both cardinality ratios and participation constants together are called as structural constant. So we do have one more ER diagram for that structural constant. Before that, I'll just tell you about the naming of schema construct. What is the naming convention that we are using when we are writing an ER diagram? So I'll take up this diagram so it is more visible and it's clear also. I do have role names. The entity types are denoted with uppercase letter. It indicates it may have no plural is there. So it indicates a set of instances of an employee or individual entities, E1, E2, E3, maybe up to 100 entities. So it will be denoted with uppercase letter within the rectangle. And the attribute names are denoted with first letter uppercase followed by lowercase, the attribute names. So that is the convention used for denoting the attributes. And relationship types are denoted with uppercase letter works for, but these relationship types should have to convey some proper meaning. It's so you are free to choose the names, but only thing is it should have to convey some proper meaning. Employee works for department. So if you don't want to give works for here, employee will work for department. You can give it employee X department means it's not going to give convey proper meaning. No, that's why we have taken works for department. Employee manages department. If you don't like manages, employee MAN department, you can write down like that. So it's not going to convey meaning. Manages is the right word to choose for the relationship type name. Employee supervise an employee. So now left to right, we can read from left to right or from right to left. Now I'm reading from left to right. Employee works for dependent. Employee dependents of dependent. I cannot read like that. From bottom to top, I'm reading. So left to right reading and from bottom to top reading, I'm associating. Dependents are dependents of employee. If you want to change it, employee will have dependents. Just give proper some names. So that name should have to convey some meaning. So this is the AR diagram of min-max notation. Min means minimum number of times that an entity can participate in relationship type, and maximum number of time that an entity can participate in relationship type. Now I'm discussing about min max notation here. If employee exists, minimum number of times it should have to participate in works for is 1. Maximum is also 1. See this side. Department. Minimum number of times 4. Maximum is n. That means department can have minimum number of 4 employees. Maximum, we don't know, n. Department needs to have at least 4 employees. Maximum is n. See this side. 0. Minimum is 0. Why 0? Because not all the employees are managing the department. That's why it is 0. Maximum 1. This side, minimum is 1, maximum is 1. We can't denote 0 here for minimum time because the department exists, then it needs to be managed. That's why it is 1:1. Now, one employee works on one project. Minimum is 1. If employee exists, he has to work on some project. This maximum n. That means project can have one employee or project can have n employees. Employee needs to work on minimum one project, maximum he can work on n projects. Now employee John Smith works on project X. John Smith also works on project Y. John Smith also works on project Z. So that means 1:n. Now project when one will have John Smith, project one will have Bob Wills, project 3 will have Stuart Williams. So that means one project have n employees. So this is the min max constraints. So the participation constraint and the cardinality ratio both together are called as structural constraints, that is given here. So and we have min max notations also. It's very important, ER diagram notations and ER diagram. So with the help of all the concepts that I have discussed and the notations, now it is easy to write an ER diagram. So here is an ER diagram. Employee, for the requirements that we have listed in the previous session. Employee works for department, employee manages department, department controls project, employee works on project, employee will have dependents, employee is managed by supervisor. Now we'll look into one more ER diagram, bank database. Requirement, you can assume your own requirement. A bank will have many branches. Branch will provide a loan. Branch will have accounts. So so customer holds account in a bank. So these are the things. Attributes you can assume on your own. Bank name, code, address, main bank address. Bank has branches, branch ID, branch name, address. If you want to populate other attributes, that's well and good. You can add it. What are the other kinds of attributes that you can add here is total assets in branch and how many employees are there in branch, who is the manager name, all those stuffs you can add up over there. Branch offers loan. So right now I'm reading from top to bottom. Branch offers loan. Loan will have loan ID, loan type, loan amount. Branch maintains accounts. Account number, account type, whether it is a saving bank account or current account or joint account, balance. So customer holds account, customer name, customer ID, phone, address. Customer avails loan, loan availed by customer. It's left to you in whatever the order you can read it. See here, total participation. All branches may not give loan. That's why it is partial here. All branches may not give loan. So if loan is exist, it should belongs to some branch. That's why it is total here. Okay. It should be total here this side. Branches, if branch exists, then that needs to have some accounts. It should be total. You can add up one line here. Customer, both the side it is total. If customer exists, then you need to have some account in the bank. So this is a simple ER diagram of bank database. You can write an ER diagram for hospital database. You can also write an ER diagram for movie database, library database, college database, university database, and then transportation database. Like this, you can write many ER diagrams. So in the exam, you may get the requirements about the ER diagrams. You may need to write the ER diagram. So this is entity, attribute, relationship type, partial key, primary key, key attribute. This is partial key. Identifying relationship type is this one. No identifying relationship types are there. Sorry. That's it. These are the cardinality ratios. So some of the questions related to the topic that we have discussed so far. The first question is entity relationship set is represented in ER diagram as double diamond, undivided rectangles, dashed lines, diamond. How we are representing the relationship type? Using diamond. Second question, an entity set that does not have sufficient attributes to form a primary key is termed as weak entity. If entity does not have a primary key or key attribute, that is called as weak entity, and weak entity is identified using partial key. Third question, which of the following symbol represent the relationship sets in ER diagram? I think this is repeated. Diamonds is the answer. An entity set that has a primary key is called as strong entity set. So it's not weak entity. If entity does not have a primary key, that is called as weak entity. Still true or false? Every weak entity set must be associated with the identifying entity. That means weak entity should have to be associated with the owner entity via the identifying relationship type. So that is true. Answer is true. What is a relationship called when it is maintained between two entities? That means if two entities are participating in the relationship type, then it is called as binary. There is no concept of unary relationship type. Either it should be binary, ternary, or quaternary. If three entities are participating, then that is called as ternary. If four entities are participating in the relationship type, then that is called as quaternary. So that will be the end of this session. Thank you.